Okay, so this lesson is basically about how to categorize the numbers that we're going to be working with all school year. The categories that we're going to be working with start with the great big or the biggest set of numbers that we have, which is this set of real numbers. So they're using this rectangle right here to represent all the real numbers. Um, the real numbers, based by definition, here's the definition that I'm giving you up here. The definition of a real numbers is a set of numbers that contains all rational and irrational. Well, that's not helpful especially if you don't know what rational and irrational numbers are. So, what I tell my students is that real numbers are that might make a little bit more sense to you is you might want to add that they're all the numbers on a number line. Okay, so anytime you draw a number line, that number line contains real numbers. So -2, -1. Now you know whenever I draw a number line like this that I'm not, it's not just the numbers that I have right here located. I've located those numbers on the number lines. You know that there's a whole bunch of numbers in between, and the numbers in between those, the numbers that I have indicated right there, are all those fractions and decimals. Okay, so numbers on a number line, that's the real set of numbers. Then you break those up into two different groups. You have rational numbers, like down here we see this big group right here. We have rational numbers and we have irrational numbers, and the basic difference between those is what their decimals look like. Rational numbers have nice decimals. For example, they have 5/7 written right here, and if you change 5/7 into a decimal, it is what we call terminating. It at first glance looks like it goes on forever, but it doesn't. It terminates. This 20 over 5, it terminates. It turns into 4. Okay, 2/3. That one doesn't terminate. It goes on forever, but it's repeating. So the definition says if you can write it in the form of a fraction, then it's a rational number. Well, what numbers can we write as a fraction? We can take decimals that terminate or have repetition, and we can change those into a decimal. So that means that irrational numbers, therefore, never terminate and have no repetition. And it's basically going to be one pretty much kind of number. Well, there's pi. Pi is a very special one. It comes from the relationship that happens in a circle between the circumference and the diameter. That's where we get pi from. But all the other numbers that are going to be irrational are going to come from taking the square root of a number that's not a perfect square. So this is where we're going to get those decimals that don't repeat and don't terminate. They just go on forever. So those are irrational numbers. And like I said, we know that those we talked about the other day when we were placing. Remember, we placed, let's see if we can place let's put on here, where would the square root of 2 go? Well, the square root of 2 is going to live somewhere between the number 1. Here's the number 1, and we know that also can be written as the square root of 1, and the number 2 right there is the square root of 4. So we know the square root of 2 is going to live somewhere in here because it's between the square root of 1 and the square root of 4. So it's going to live somewhere in between 1 and 2. But it's going to be a non-repeating, non-terminating decimal, and I can show you on the calculator what that is. So if you were using the TI Nspire calculator, you would type in the square root of 2, and it would show you that many decimals, but that's simply because it ran out of space to write them all. It does not, it's not able to show them all. So I would probably write down 1.4 0.41. So I would write down a little equal sign, a wavy equal sign, and that would be 1.41. That would probably be enough decimals. So it's going to be located somewhere between 1 and 2 at about a little bit less than 1.5. 1.5 would be right in the middle, so it's going to be a little bit closer to 1 than it is to 2. If you don't have, obviously you don't have the graphing calculators at home unless you bought one, you can always go to a Desmos calculator. I just Googled Desmos calculator, turn on the little keypad that's down here, hit the square root button and type in 2, and it'll show you right here, probably those same decimals are very close to the same number. So, I think I've heard them referred to as mumbo jumbo decimals. Mumbo jumbo meaning that they're all mixed up. There's no pattern, there's no repetition, and there's a whole bunch of them. So mumbo jumbo decimals. I call them ugly numbers. Man, that's an ugly number. However you want to think about it, just remember that those are the ones that are irrational, non-repeating, non-terminating decimals. Then after we take these rational numbers, we can group the rational numbers into a few other groups. Integers, I think we've already used the word integers in class. Integers are both positive and negative whole numbers. There are no decimals or fractions in the set of integers. Again, no decimals, no fractions. So that might be what you want to put right here. I'd put no decimals, no fractions. No decimals, no fractions. That's your set of integers, but you have both positive and negative numbers, and you have 0. The next two set, the whole set and the natural set, the natural is sometimes called the counting, because those are the numbers that we usually use to count with, the counting set of numbers. The only difference between the whole set and the natural set is the number 0. The whole set includes 0, the natural set does not. That's why I like to think about those as numbers that we count with. This thing down here, this picture down here is called a Venn diagram. It's just a way of show how things are related to each other. The reason that these circles right here are inside this other circle is because if you are an integer, you automatically are already a rational number. So natural numbers are also whole numbers, because as you notice, here's the number 2, and the 2 is in the natural set, the 2 is in the whole set, the 2 is in the integer set, and the 2 is going to be on our number line over here. So since it's on the number line, we know it's a real number. So the number 2 would belong in all of those groups. On your assignment, you're going to be asked to name all the sets that each one of these numbers belong to. So everything on here is going to be a real number. In Algebra 2, you learn about numbers that are not real, and those numbers are called imaginary. I don't think we do that in Algebra 1. So all of these numbers, notice the real set has been listed on every single one of them. The real set, because all of these numbers are real. You will find them on the number line. So the first thing you need to do is figure out, do they have a decimal or not? This one does not have a decimal, so we know it's rational. So they're all real, no decimals, rational. It's a negative, so it's an integer. So how would I rate this one? It's real. It is a fraction, so it's rational, and that's as far as we can go since it has a fraction, and you can look at the decimal value or the fractional value, either one. They're showing you the decimal value right here to prove to you that it is a terminating decimal. It stops. These numbers right here, they ask you to put them in the right place. Again, it has to do with the way it was defined. So look at these examples and try to understand why they were placed where they placed, and then use this set of notes to do the assignment. that came along with this. I believe this is activity. Oh gosh, I missed it. I believe this one is activity. I don't have them numbered. Anyway, you've got the numbers, okay? We'll talk about this and grade this on Monday.